Hello everyone, organizer and participants. My name is Ayuni Nabilah, Alias, and I'm Senior Lecturer at University Putra Malaysia. I'm very thrilled today to be presenting at the second International Conference on Advanced Engineering and Applied Sciences 2024 via virtual presentations, where I will be sharing insights on a topic that crucial for improving motorcyclists' daily comfort through this research of muscle relief on the road, evaluating a novel armrest for the motorcyclist. So my paper ID is number 9. During this presentation, I'll be walking you through the introduction, methods, findings of armrest prototype in results and discussion, and also recommendations for future research in order to have a better visions of motorcyclist ergonomics and prototype design. To kick these things off, did you know that proper armrest support can reduce the shoulder and neck strain by up to 40%? This fact alone underscores the importance of this research today. Thank you for joining me today, and I look forward to sharing this exciting journey with you. Motorcycles are a popular, cost-effective mode of transportation in Malaysia and many other parts of Asia. According to the Ministry of Transport Malaysia, over 700,000 new motorcycles were registered in 2022. Despite their popularity, motorcycles often feature ergonomically inappropriate riding posture, leading to discomfort and musculoskeletal disorders. Motorcyclists face significant ergonomic challenges due to static sitting positions, limited support, and lack of bed rest. This often results in discomfort, muscular pain, and also musculoskeletal disorders. For ergonomic principles, ergonomics aims to enhance human well-being during product use by reducing discomfort, enhancing work satisfaction, and preventing long-term disability. Our design philosophy is design for the people, focusing on the needs, expectations, and stability for the users. And with that, our study aims to address ergonomic shortcomings in motorcycle design, develop the armrest prototype to minimize muscle activity and discomfort, and enhance the long-term health and well-being of the riders. For the methodology, we employ a pre-post-test experimental design in a control laboratory to evaluate the effect of the armrest prototype on muscular stimulations. Through this study, we recruited 102 male motorcyclists aged between 20 to 35 years old, regularly riding motorcycles of 150cc or less, and divided them into 2 groups. For selections of participants in this study, we had inclusion and exclusion criteria like listed in this slide. Our armrest prototype is designed for maximum comfort, which is to enhance motorcyclist satisfactions, promote longer use of the product. Second is adjustability. This prototype can be adjustable in order to fit into the handlebar of motorcycle. Next is durability, which is designed to last, of course, with proper maintenance, and with that, reducing the need for the replacement. And last one is repairability, which can easily repair rather than replace. This can extend products' lifespan and reduce waste for a better environmental impact. Electromyography setup, we use surface electromyography (SEMG) to measure muscle activity in the flexor carpi radialis and ulnaris muscles during the riding sessions, both with and without the armrest. As you can see the figure on the side, the EMG equipment used for this muscle activity that we call it as a power lab recording, which we place the electrode on arms like in the figure. Skin was cleaned with alcohol sweat before it, and let it dry to have a better capturing signal of muscle activity. This is the overall flow of the experimental prototype testing, which started with the participants need to complete two sessions, one with the armrest and one without the armrest, which each station lasting to 2 hours with a 3-day break in between. This is to ensure participants have a better rest before they join for second sessions of prototype testing. While they ride on motorcycle in lab setting, there was simulator displaying a simulated road scenario that needs for our participants to have a handlebar motorcycle movement. At the same time, electrodes that attached to both their arms had captured their muscle activity until the session ended after 2 hours. Based on the results show in this slide, it shows a significant reductions in electromyography levels in both right and left arm muscles when using the armrest prototype, which indicating improved comfort and reduced muscle activation. As you can see in both figures, both graph line for experimental group were reduced significantly compared to control group after being tested with the armrest prototype. Next, as overall results, by analyzing using fragment test, there was a significant reduction in muscle exertion during 2 hours riding with armrest that were captured for every 15 minutes in details. This one that you can see p-value, which is less than 0.0001, show that significant reductions for overall muscle activity among the participants. With that, armrest primarily is intended to improve their comfort in a very restricted space, which is motorcycle, and that can contribute to better and safe riding, especially in long rides. Throughout this experimental testing, prototypes have been tested in a laboratory in order to reduce or eliminate the effects of confounding variables like weather and other normal road activity that might cause any effect on muscle activity recording. As previous research mentioned in their studies, motorcyclists frequently feel discomfort on hand and arm, especially during long ridings, cause muscle tensions that give discomfort and pain to a related area. Ergonomic solution like this can exert less force, especially on static posture, and improve overall riding comfort motorcyclists. As conclusion, our study demonstrated the significant benefits of ergonomic intervention in motorcycle design by lowering muscle activity and reduce strain on hand and arm muscles. The importance of ergonomic solutions in motorcycle not only improve riding comfort, but also add to a long-term physical health. And with that conclusion, we hope we can bring up new possibilities for future research by investigating the biomechanics of armrest design that focus on analyzing user satisfactions and their comfort level. Better design should be explored with environmental impact in design, should be considered and implement the psychological benefit of comfort due to the sustainable design. And of course, collaborations with experts such as health professionals with new materials and technology can enhance a better sustainable design for the rider ergonomics in future. This is the list of my reference that I used throughout my slides presentation. And lastly, we would like to express our deepest appreciations to the motorcyclists who participate in our study, and they willingly to spend so many hours to complete the experimental sessions. Your contributions have been invaluable to us as the researchers. With that, I end my presentation. Thank you. Thank you for your attention. And I am now open to any questions that you may have, that you can send those questions through this email. I will get back to you as soon as possible. So thank you, everyone. Thank you, organizers. See you in a next conference.